Hi everybody, let us see torque equation of a DC motor, uh, especially the electrical equivalent circuit of a DC motor is V applied voltage, unit is B, EB back EMF, RA armature resistance, unit is ohm, IA armature current, RSH RF shunt field resistance, IL linear supply current, TS developed torque motor or armature torque, TSH shaft torque. In this torque equation, we have to calculate the back EMF of EB is always less than the applied voltage V. Since back EMF EB acts in opposition to the supply voltage or applied voltage V, the net voltage across the armature circuit V minus EB. Then we calculated the torque equation of TA always be the product of force and radius across the conductor circumstances. So we pick that value. Back EMF is P pi Zn by 60A. Already I told P is pole, pi is flux, Z number of conductor, N speed. Now we just rearrange that back EMF as such P pi Z by A equal to 60 into EB by N. This is basic torque equation while induced of back EMF. Now go through the speed angular velocity W equal to 2 pi N by 60. This unit is radians per second. So always a DC motor having some initial torque, that torque contains force into radius of the conductor. So T equal to F into R. Torque unit is Newton meter. F is distance moved. So distance moved always depends upon the circular motion of radius 2 pi r joules. So P is power developed. The power developed always depending the conductor work done by how much work carried out by how much time. Okay, work done is F into 2 pi r by time is 1 revolution, 60. So F into 2 pi r by 60, RPM is 60. RPM in the sense a speed unit RPM. So this speed RPM could be calculated by RPS, N speed by 60. So time for 1 revolution 60 by N. You could replace this 60 by N across that R value P equal to F into R 2 pi N by 60. So come out P equal to T proportional to watt. This is torque equation of DC motor. Finally, this DC motor can receive the speed equation also N proportional to back EMF and generated flux across that motor. Then this is application of DC motor. Each characteristics having some applications. That applications are shown here. Shunt motors having lathe, drill, boring mills, shapers, spinning and weaving machines, woodworking machines. Then reciprocating pumps, blowers, centrifugal pumps, mills. Series motor having locomotive, train cars, trolley cars, cranes, hoist, elevators, conveyors, winches. Compound motor contain To classification, differential, cumulative, DC differential compound motor having some applications. Battery booster, experimental and reaches. Cumulative compound motor says punching, shearing and planing machines, lift, air compressor, rolling mills, printing presses. Then let us see types of electric braking. First, we could explain about what is meant by braking. Sometimes it is desirable to stop a DC motor quickly. This may be necessary in case of emergency stop or save time. The motor and its load may be brought to rest by using either mechanical, that means friction braking, or electrical braking. In mechanical braking, the motor is stopped due to friction between the moving parts of the motor and the brake shoe. That means kinetic energy of the motor is dissipated as heat. Mechanical braking has several disadvantages, including non-smooth stop and greater stopping time. So it contains some classifications: rheostatic or dynamic braking, plugging or reverse current or counter current braking, regenerative braking. This braking may be noted that electric braking cannot hold the motor stationary and mechanical braking is necessary. However, the main advantage of using electric braking is that it reduces the wear and tear of mechanical brakes and cuts down the stopping time considerably due to high braking retardation. So among those three braking, let us see rheostatic or dynamic braking of DC shunt motor. Yes, the dynamic braking is used to stop the motor by dissipating its stored kinetic energy into resistive load or external resistance or braking resistance. Once the kinetic energy is totally dissipated, the motor stops rotating if no external torque is exerted. In this method, the armature of the running motor is disconnected from the supply and is connected across a variable resistance R. However, the field windings remains connected to the supply. The armature, while showing down, rotates in a strong magnetic field and operates as a generator, sending a large current through resistance R. This causes the energy possessed by the rotating armature to be dissipated quickly as heat in the resistance. As a result, the motor is brought to standstill quickly. This type of braking is used extensively with the control of elevators and hoist and in other applications in which motor must be started, stopped and reversed frequently. For a shunt motor, flux is constant, braking torque proportional to speed. So this dynamic braking or dynamic scheduled has some advantages and disadvantages. That's all. This method is effective and the motor stops very quickly. This method is adopted for non-reversing drives where regeneration is not possible. It has some disadvantages. That disadvantages are generated energy is wasted in the form of heat loss at resistance. This method is efficient in case of failure of electric supply. So, some advantages is effectively to use to this braking, dynamic braking. So, this dynamic braking somewhere most preferable method and acceptable method. Thank you.